So let us see about dot product today. We are going to understand dot product for vectors. So let us proceed. Under dot product, we actually consider multiplication of vectors. Multiplication. Okay, it's called multiplication of vectors. So we can multiply in two ways. First way is the scalar product. So you get a scalar result. Or this is called as the dot product, which we are going to study here. And second way is a vector result or vector product. Scalar result or scalar product. And this is a cross product. So today we are going to study about scalar product. Okay. These are the two ways of multiplication. One is the dot product and another is the cross product. Dot product gives us the scalar result and cross product gives us the vector result. So let us understand about dot product in this particular session. Dot product or scalar product. Okay, let us consider two vectors. We have two vectors here. This is vector A and this is vector B, and this is the angle theta between them. Then the scalar or the dot product is written as A dot B is given as A B cos theta. So let us understand what this actually means. Let us resolve vector B into the components parallel and perpendicular to vector A. Let us resolve this vector here into parallel and perpendicular component to A, right? So basically parallel to A will be like this, and perpendicular to A will be like this, right? This will be perpendicular to A and this will become parallel to A. So parallel to A component will be, this is on the x axis, it will be x is equal to, parallel component will be B cos theta, and the perpendicular component will be, what is the perpendicular component? B sin theta, right? So A dot B is given as A into the parallel component B cos theta. So what we can see here, dot product is the product of magnitude of A. It's the product of magnitude of A. Let me write it as magnitude of A and magnitude of component of B along A, right? The magnitude of component of B along A. So here B cos theta is the projection of B along A, right? B cos theta is a projection of B along A. Let us consider the other way. Let us consider the projection of A now on B. Let me clear this. We had two vectors like this, and we had A here, we had B here, right? Now we want to consider the projection of A. Projection of A on B will be A cos theta. So A dot B will become equal to the component of A parallel to B, right? Component of A parallel to B. So we can write it as A cos theta B. So we can write this as A B cos theta. So either way we have the same result. That means A dot B is equal to B dot A. This is the beauty of a dot product. So dot product is, we saw that dot product is commutative. Dot product is commutative. So let us see some few properties of a dot product based on the angle it makes with both the vectors. Okay. The first property, what are we going to see? Properties. Properties of dot product. Dot product. First case of first property is when theta is less than 90 degrees. Second property will be when theta is greater than 90 degrees, and so on. So first we'll consider theta less than 90 degrees. So we'll have two vectors here, and this is theta less than 90 degrees, right? So the dot product will be so what will be the dot product? A dot B will be AB cos of theta, and if theta is between 0 degree to 90 degrees, then the values will range from 0 to 1. So that means A dot B will be a positive dot product, right? Second case is when theta is greater than 90 degrees. So here what happens, becomes a obtuse angle. This is theta greater than 90 degrees. This will consider B this time, this will consider A. You could consider anything. So here theta is greater than 90 degrees but less than 180 degrees. So what will happen to the dot product here? Between 90 to 180, we know that cos will be turning negative. So A dot B will be a negative value when theta is greater than 90. So third case, I'll wipe this out. Third case, let us take third case. Third case is when theta is equal to 0 degrees. That time what will happen? Both will be parallel. This is A, this is B. So dot product will be A dot B will become equal to AB cos of 0, and cos of 0 is 1. Cos of 0 is 1, so it will become equal to AB, right? That means AB will be max when it is 0. Fourth case is when theta is equal to 90 degrees. So that means it will be something making 90 degrees to each other. A, B. So then the dot product will be A dot B will become AB cos of 90, and cos of 90 is 0. So dot product will be 0. So here what we get? Here we get minimum, right? Will we get minimum here? No. Negative case for the minimum case. Okay. Negative case for the minimum case when theta was between 90 and 180 degrees. So now that we have understood the various properties of dot product, in our next session we are going to cover cross product. Okay, this was all about dot product. Let me summarize it. Dot product, dot summary. This is the dot summary. This is the dot summary. There are two ways to multiply. One way is the dot, which is a scalar product. So it is given as A dot B is given as AB cos of theta. So it's basically a reflection of either one of the component parallel to that particular vector. If you have B here and this is the angle theta and this was A, then the reflection of B along A is basically B cos theta. Right? This is how it is supposed to be read. And then we saw the different cases when theta was less than 90, then it is, if theta is less than 90, it is positive value. If theta is greater than 90 but less than 180, then it is negative. When theta is equal to 90 degrees, that time what will happen? See the first case, second, third. When theta is equal to 90 degrees, A dot B will become, cos of 90 is 1, so it will become maximum. It will become equal to A dot B, right? And the fourth case is basically when theta is equal to 0 degrees. Sorry, when theta is equal to 90 degrees, this was 90 degrees, that is actually 0. Okay? Cos of 0 is 1, right? This is 0 degrees and this is 90 degrees. So A dot B will become 0 here. Okay, because cos of 90 is 0. So this was the summary for dot product. So let us move on to cross product. So like, subscribe and share to your friends so that they can take the maximum benefit of our channel and learn the in-depth of physics.